We're looking at the continuity of a function in a closed interval. So till now we have seen open interval and point. Now we're looking at closed interval. The very basic question is, why is that we are looking at open and closed? You could have used closed, right? See, open, we have to have the basic idea of open because we have functions which will vary from minus infinity to plus infinity. So in such cases, we will make use of open interval. Of course, there are many other cases, but this is the most fundamental one. And closed interval, we have seen that in inverse trigonometric function and all of that. So few of the places we need those functions badly, and those functions will be defined for particular set of intervals. And in such cases, we can use closed intervals. Again, case by cases, we will vary things. So this is a fundamental aspect. Keep this in mind. Like before, the basic idea over here is we are drawing smoothly from one end of the function to the other end without lifting the pen, including the extreme points. So basically, we're including this, we are drawing and including this as well. So continuity at a point x implies that the function as x approaches that point exists and is equal to the value of the function at that point. So basically, we have seen this limit x tending towards some value is equal to that value, and this value is between a and b, and it's part of your real number. So in such a case, the function is continuous for all x in this interval. So that's our a, that's our b. Now, here again we have an example. You can see it's x squared minus 3 itself. And that's our output. Yes, it's similar to what we have seen before. See, this is our open interval. This is our closed interval. So we have the extreme points of minus 3 and the function is smooth, as you can see, and it goes to the other end, plus 3 as well. So that's your example. Again, I'm making it as simple as possible. There are complex version of things, so that we'll see as numericals. So this is just introduction. So we're including the values, and we had this graph. So that is minus 3 and this is 3. F of x. So in this case, the function is continuous for all x in the interval of minus 3 and 3. So there is a small thing that we have to keep in mind before we start with the exercise question. Continuity of a function at a means, see, we are talking about a is over here and b is over here. We can approach the point of a from the right hand side, while we can approach the point b only from the left side. And so only this two will be valid in the case of closed intervals, and no other case it does not come the other way around. It has no meaning. So we are not looking at proving limit x tends to a minus f of x is equal to f of a, or the other way around over here. So this is something that we have to keep in mind when we are dealing with closed intervals. Okay, so all this is commonsensical. It should not be too hard. Okay, so with all of this definition, we can start off our exercise. Actually, there are a few more concepts, but this is pretty much it. So you can pause and have a look.